Hello, 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 grade 11s. Yes, Learn Extra Live is back for you. We are back on your TV screens. We hope that you guys did not miss us too much. Yes, we dearly, dearly missed you, trust me. My name is Queen Matoso, and as always, of course, I am not alone on this lovely show. We've got the awesome teacher in studio with us, and it is Dina. How are you, Dina?
Hi, Queen. Hello, everybody. I'm very, very well and ready for today's show.
Guys, just look at Dina's hair. Is it not amazing? Just give me your hair, Dina. Well, guys, remember that you can connect with us. The show is all about you. All you have to do is simply log on to our Facebook page, all our social media pages. We've got Twitter. We've even got the website where you guys can get yourself notes, buy yourself some textbooks and extra videos, all learning resources that you need to make sure that you pass your exams. And that is on learn.mindset.co.za. That is our website. Or on Facebook, you can find us at www.facebook.com/learnextra. Or you can also find us on Twitter, and our Twitter handle is @learnextra with an X. Don't forget the X, guys. And we've got so many competitions for you guys because we love you that much. We've got our Get Connected competition back with us right here on Learn Extra Live, and that is by simply remember that you guys voted for your favorite teachers, and now we've got 6 final teachers that are left. So all you have to do is simply log on to Curio. If you're not registered, remember to register. Like your favorite teacher's picture on Curio. Come onto our Facebook page. Like your favorite teacher's picture on on our Facebook page as well. You can share the page, guys. Make sure people know about it. Make sure your friends also vote for your favorite teacher, and you stand yourself a chance to win airtime, loads and loads of airtime, and a Sony Xperia L. Now, I'm so jealous because I actually can't really enter the competition because, I'm part of Mindset, so I'm not allowed to enter. But you guys have that opportunity, so please make use of it. But without wasting any more time, let's get straight into the show. After all, that's why we are here, to learn and equip ourselves. Dina, what do we have for the grade 11s today?
Grade 11s, we are doing that very wonderful topic called statistics, the ability to look at data and organize it in a way that we are able to extract some valuable insights into our whole range of data. So that's what we'll be doing.
Oh, wow. That sounds very interesting. Now, remember, this is a topic that I actually kind of struggled with in grade 11, but that's why we have Mindset Learn. That's why we have teachers like Dina who are going to be here for us and help us through this journey.
So, grade 11s, let's have a look at what the purpose of our lesson is today. We're going to represent data, and we're specifically going to talk about something you've already dealt with, the measures of central tendency, as well as the way that data is dispersed around those measures of central tendency. We have obviously our challenge question to start us with, and for those of you who have already covered quite a lot of these topics in grade 10, let's have a look at what the challenge question is about. There is a rabbit called the riverine rabbit, and it's one of the most endangered animals in southern Africa. It is estimated that there are less than 250 of these rabbits left in the wild. Now, 60 riverine rabbits their masses were measured, and a box and whisker plot has been drawn of the rabbit's mass. The challenge question is to comment on the distribution of the box plot, to calculate the values for A, B, C, and D on the frequency table below, and we'll leave you to ponder on that and send us your answers. How do you describe that box plot, and can you find the value of A, B, C, and D? All right, grade 11s, that remains to be the challenge question. The summary, just for those of you who are new to this topic, is that the central tendency is not really an exact science. So even though mathematics, we always want that final answer and it's got to be very accurate, statistics gives us a little bit of flexibility within which to talk about the various data points or the various central tendencies that we get. So we look at the mean, we look at the median, we look at the mode. You've been talking about these since grade 9. And the mean would be a number that when you take all the values and you add them together and divide by the total, you get this middle number that we talk about, so this average, often called the mean. The median would be by ordering the data from smallest to largest, it would be the one that that would fall directly in the middle, the value that you get that splits that data into two. What is that median value? And then we've got the mode, which is a value that is occurring the most times. So that would also be a measure of central tendency. How do we center this data? So we can center it in three ways, and no one way is more exact than the other. It's just giving us a story about the context. So if you had, for example, your classmates, and there are 40 of you in the class, and you wanted to work out what is the measure of central tendency of your heights, you may want to take an average of the heights, or you may want to take the median. If you look at your marks, you've got 6 subjects, 7 including your life orientation. You may want to take the average of those 7 subjects. You may want to take the median, and you may want to compare those. And maybe your marks on your report should have a median instead of a mean. So it is a measure whereby we center our data. And like I said, there's no one exact science. Then dispersion, I think, is something that you do new now in grade 11. You may have not talked about how is the rest of the data distributed in relation to this measure of central tendency. And the word we use is dispersion. How dispersed is that data? Is it widely dispersed, or is it concentrated about the mean? Because if it's concentrated around that measure of central tendency, it's telling us one thing. If it's scattered, it's telling us something else. So if you're talking about the way that it's scattered around the mean, then we call it the standard deviation. And if we talk about the dispersion around the median, we talk about the interquartile range. So the median doesn't have a standard deviation, and the mean doesn't have an interquartile range. So those are the two words that we connect with those two measures of central tendency. Okay, the first question that I've used to give us an example actually came from the grade 12 paper, which I marked way back in 2009. And I found this question very interesting because it contains both measures of central tendency, so that you can see the differences. And the data was actually captured at the Cape Town airport, and it looked at the total monthly rainfall, which was captured in millimeters at the airport. So to get a sense of what's happening in the data, we have January that had 60.9 millimeters of rain. We had February with 14.9. We had March with 9.3, April with 28, May 71, June 76, and so on. So we can see that these months here, the winter months, are when Cape Town experiences the most rain, and then it peters out with the other months. So the first thing you need to do is to really understand, what is the data telling me? What have I got? So I've got 12 months of rainfall, and I've measured each month's total rainfall, and it's been given to me in millimeters. So we're understanding that the data we're capturing is the millimeters of rain. Then they ask, determine the mean monthly rainfall for 2002. So how do we work out the mean? Well, we take every single data value. How many of them are there? There are 12, and we add them up, we divide by 12, and we get the mean. So if we had to use our calculator, that would be 60.9. We would then add on 14.9. We would add on 9.3. And I'm not doing anything because I'm just adding these numbers and I'm dividing them by 12. So if I make a mistake, I can't really go back. So grade 11s, let me go back and say that there is actually a mode on your calculator that is able to calculate the mean. And you'll find it under setup. It's the mode saying stat. So you'll click on that mode, and you'll then get a menu that gives you various numbers of various things. And the one that you want to click on is one variable. That stands for variable. So it's number 1. And you'll see now the word stat appears on your calculator, and your X's are all the data points that we're going to enter. So we're going to enter 60.9. We're then going to say enter by pressing the equal sign. So it's now got my data point. 14.9, 9.3, 28, 71.9, 76.4, 98.2, We're up to July. So August is 65.7. September is 26.1. 32.5. 23.6. And finally 15. Okay, so the calculator is now showing me it's entered 12 data points and it's got it all in. The beauty of this calculator is I can clear it. It's disappeared, but it's kept it in its memory. So if you go Shift 1 under the Stat button over here, I can recall my data is in 2. And there's my data all over again. If you had to change the mode or the setup again, it will clear it, but for now, it's keeping all that data. So how do we go into... so now it wants to edit, etc., but I don't want to do that, so let's just clear. Okay, so I want to be able to get to my VAR stands for variance, so it's in that menu, and in that menu you get all these symbols. You get 1 is how many values there are, excuse me. 2 is X bar, which is the symbol for mean in mathematics. And then you get this number 3, which I'll speak to you about in a little while. So the mean is what we want. Let's just have a look at 1 so that you can see that we've entered 12 data pieces. And there it is, 12 data pieces. N stands for the total number that you've entered. Then you go back into 1. And 4 is the menu that you want. And X bar is the mean. And you can give it equal. So the mean is 43,54. So at Cape Town International, we could say that they can get this middle number of 43,5 millimeters of rain. That's kind of the average for all the months that are taken into consideration. But now you'll see that there's a huge difference between 43 and 98. There's also a huge difference between these two values. There's not such a big difference between 43 and 28. And there's a big difference between 43 and 9. And there's a big difference between 43 and 14. So the way that these millimeters are now placed around the mean, some of them are a big distance away and some of them are a smaller distance away. And we want to take an average again of what these distances from the mean are doing. And when we do that, the calculator's done all those calculations for us, and it's now under number 3, which is what we call the standard deviation. So what we're now saying is, remember I said to you there was a huge difference between 43 and 98. We are saying that the standard deviation from that mean is 28 millimeters on either side of that 43. So if we add on 28 to 43, we're going to get quite a lot of these other numbers. So that's telling us how dispersed the data is. So the data points around the mean are spread around 28 millimeters. So that is called our dispersion. 28 millimeters is on either side of our mean, which was 43. So let's write down that 43,5 over here. So let's just use a pen. Okay, so the mean, which is X bar, is equal to 43,5 millimeters. Okay, then write down the 5-number summary for the data. Now, when I marked this paper, and I must have marked about 1,000 grade 12 scripts, I found a lot of students not knowing where that 5 summary comes from. And they just ordered the data from January to December. So because January was the first month and December was the last month, they said that that's my minimum and that's my maximum. But remember, it's not about the months. We're not talking about months. We're talking about the data that is under discussion is the millimeters of rain. So you've actually got to go and order your rain and decide which one is the smallest value, and I think it's this one, so that would be number 1. Then the next value would be, I think 14 would be number 2. Then we'd have a number 3 over here. We would then have a 4 at 23. Maybe a 5 at 28. Here's a 5 at 26. Then this would be my 6th value. Then after 28, I get a 32, which is my 7th value. Then I get my 8th value, which would be 32. What's after 32? Maybe 60. So this would be my 8th value, 9th value, 10th, 11th, and 12th. So my first value would give me my minimum, and my largest value would give me my maximum. So rainfall can be 9 millimeters in one month, and it can be 98 millimeters in another month. So we're making sense of the range of the data, okay? But then we would order these in a line, so we can see where the Qs are going to fall in. So we would have a 9,3. Then we would have the 14,9 and 15. Then we would write what our fourth one is, which is 23,6 and 26,1, 23,6 and 26,1. Okay, then we would have our 28 and 32,5. 28 and 32,5. Then we would have 8 and 9, which is 60,9 and 65,7. 60,9 and 65,7, and I'm running out of board. And then we're at number 9. So 10, 11, and 12 would be these three, 71,9. I really needed a bigger space. And 76,4 and 98,2. Okay, now we have 12 pieces of data. So when we bisect the data to get the median, it would be 1, 2, 3, 4, 5, 6. That would bisect my data. Now, on this pink line, I don't have a data point. So should I take my 28 or should I take my 32? So what I do is I add the two up and I take an average of those two. And that will be my median. So this value here is my middle value, which doesn't exist on my data. Okay? Then I can take these 6, and out of these 6, that bisects the data. There's 6 this side, there's 6 that side, 1, 2, 3, 4, 5, 6, and we can now, there's actually 6 here, 6 values there. We can now talk about where must I bisect the data. So it's these are wonderful values to work with, because we want to get the halfway mark. So we get the halfway mark there, and again we find what is my average for these two. That will be my Q1, and then we take the average for these ones, and that will be Q3, and again that would be an average over here of these two, because that bisects. So when we have an odd number, my middle value will be one of my median, or Q1 and Q3, whereas now this data has been bisected by these two values, and that average would actually be my Q3 value. And in that way, I found my 5 number summary. Are we ready for a break?
Yes, but before we go for an ad break, can I quickly ask you a question from Umbali Tanjani? And she wants to know, how do you put the numbers in a calculator for a data table? How do you plot it in? Can you
How do you put the numbers into the calculator?
Yes, for the data table.
Okay, that's perfect.
Okay, I think we can continue with that after the ad break.
Certainly.
Let's quickly go for the ad break, guys. So we'll see you when we return from this. Welcome back, grade 11s. Hope you guys refreshed yourself during that ad break, as we are about to get ready to learn some more on the statistics topic. But before we go into that, I'd like to just tell you guys about this very massive, like personally, I feel like this is a really good competition where you can get to win yourself a Chevy Spark, guys. One of 4 Chevy Sparks that we, Mindset, together with Safeway's K53, are giving away. Now imagine a car. Who does not want a car? Now let me tell you how you can get yourself to win that car. All you have to do is, if you, like myself, are on a mission to get yourself a learner's license, simply buy yourself a copy of the Safeway's K53 Learners and Drivers Manual. Or you can also even simply download the app from the Samsung Galaxy App Store. Now, how easy and simple is that? And then all you have to do is just keep the receipt and enter the competition on our Facebook page or the K53 Safeways Facebook page. Now, we've got a tab on our Facebook page where you can follow more details on how exactly to go about entering the competition. But guys, I mean, you stand yourself a chance to win like a car, like definitely. So please don't miss out on that opportunity. And let's get straight back into the show. Now, before we went for the ad break, Mbali had asked Dina to please repeat for her how to enter the data on a calculator, my bad. So Dina's just going to show us that.
Okay, grade 11s, this is very, very important because if you understand how to enter the data, then you are skilled for life. It's a life skill because whenever you leave school and you've got to work with research or you're doing stats, then your calculator is your friend. You can also do this on Excel. If you enter your values, it can also calculate averages for you, but this is a very big skill. Now, you've got in this button over here next to the on button, it says both mode and setup. In the setup, you'll have 3 menus. One of them is the stats. So you need to press the stat button. When you press the stat button, a table will pop up. Now, I'm not going to clear my table because it's still got the data that we're working on for this question, but I'll repeat it again at the end when we're doing a different question so we can enter the data there. We're going to do it again. So for now, just work on your calculator and try and see in the setup, do you have 2? It's a stat mode. It must say stat. Press the stat. The moment you press the stat, sorry, you've got an extra menu. There will be an extra menu that has a number 1 with the capital letters VAR, and that stands for variance, and we'll talk about that later. And you click on the 1, and when you do that, then a table will pop up, and you just enter number 1, you press equal. Number 2, you press equal, whatever you have for your data points, and in that way, you're building up those values onto the calculator. So I hope that helped you for the time being. We will come back to it just now. Okay, so we left you with the with these calculations, working out what Q1 is, what the median was, what Q3 is. And grade 11's median is middle. So you want middles. Middle for halfway, middle for this one, middle for that. Everything's about middle. Who's in the middle? And if I don't have a middle value, I add the 2, I get an average. I don't have the middle, I add the 2, I get an average. Okay? Then that becomes my 5-number summary. And the next question was to plot a box plot. So I've already on my scale plotted the box plot so we can see it nicely there. And what are we saying here? What does the box plot tell us? Can you see when we started the question, we had the number of millimeters that fall at Cape Town. Now we're able to make sense of this data. We're saying that the middle value is 30 millimeters, but the maximum is very far away from that median. And for each little bit of your box and whisker plot, that means that 25% of your data points are in there. So 3 of my data points are in there, 3 are in here, and 3 are in here. Can you see that these 3 points here are close together, but these 3 points in here are very wide apart? So for 3 months of rainfall, they're quite widely spread out. But for these 3 months between Q1 and Q2, they're actually quite clustered together. So that gives us some indication of the range of the data. So this would be my IQR, my interquartile range, which is my measure of dispersion, which is our 68,8 minus 19,3, which would be, what, 40... Let's just check that with the calculator. 68.8, and we're going to take away 19.3, and that gives us 49,5. So that's 49,5. So there's a 49,5 millimeters range across 50% of the data. And the beauty about the box plot is it is in halves. So that is 25%, that is a quarter, that is a quarter, that is a quarter. So we have 4 quarters here, which means that the interquartile range talks about 50% of the data around the median. 50% of the data around the median. Okay, so we've got it's about 50 millimeters of water that is dispersed around the 30 that's for the median. Okay, then we're going to extend our page. Okay, so let's go on to the next slide. Okay, so we now got to make reference to the box and whisker plot, comment on the spread of the rainfall for the year. So we've already commented that the rainfall after the median is more widely scattered than the rainfall that happens before the median. So 50% of your data is spread out, and we give that a maths word for it. We say it's skewed to the right, because where there's a wide dispersion, there's a skewedness towards that side. So the skewedness is dependent upon which side of the box plot has been elongated. Whereas if all the data is perfectly symmetrical, so they're equal distances apart, we talk about symmetric data. But if there's one of the parts of the data that is like here, where we have, come on, this whole branch, or this part of the box, plus this whisker, that is much longer than that one. Wherever that elongation is, that length grows, that's how we talk about the skewness. It's skewed to the right. It's drawn out to the right. Okay? And so we've commented on that. And then it says, calculate the standard deviation for the data. Now, the reason I didn't want to clear my data is because I can clear it as many times, but if it's on that stat mode, it has kept my last bit of information. So if I go shift stat and I click on 4 for variance, then I'm going to have 1 for the number that I've put in, 2 for the average, and 3 for the standard deviation. And we said that our standard deviation was 28,1 millimeters. So what we now have is this situation. We have the median, actually the mean was, so we had a 9,3 as a minimum, we had a 98,2 as the maximum, and we have a 48, I think it was, or 43, I think. What was, yeah, 40, we had a mean of 43,5. So we have a mean of 43,5, and we are saying that if we add plus 28 on the side millimeters, we get to the mean plus 1 deviation. Sorry, that's a bit messy. Let's just tidy this up. So we get the mean plus 1 deviation. And if we take away minus 28,19 from this side, we get the mean minus 1 standard deviation. So these are the values that we are getting in here. And that's how we are spreading the data around the, that is a way that we spread the data around the mean. So this one would have been plus 43.5, and we would get 71,6. So this value here is 71,6, and this value over here minus 43.5 minus 28.9, we would get, no, that's not quite right, 43.5, take away our 28.1, we would get 15,31. Okay, so when you're talking about the average, you are now talking about that the rainfall has got a range of 15,31 to 71,6. That's the range of the data around that mean. So you're not getting months that are tightly squashed up against 43. So you're not getting months with 44, 45, 46. You're getting months that have got 28 millimeters apart and 28 millimeters apart there as well. So are the rainfalls clustered around the mean, or are they widely distributed? And I would say in this case, there's quite a wide distribution. So in both cases, in both the median and the mean, it shows that there is a wide dispersion. So I've given you the symbol for standard deviation. It is this one, is the symbol for standard deviation. The spread of the data around the mean. Spread around the mean. Okay. Right, I said to you I would promise you another question. Okay, so we've now got a table which shows us the ranks, the marks of 100 grade 11 students out of 6. So everybody in the class did a question out of 6, or in the grade did a question out of 6, and we want to know how many people got 1s. 4 of them got 1s. How many people got 2 out of 6? 10 got 2 out of 6. 3 got 27 out of 6. 4 got out of 4, 39, out of 5, and out of 6. So 6 out of 6, there were 8 people who got full marks. And these learners add up to 100. Okay, so now you want to work out the mean when you've got the frequency. So it's not just 1, 1, 1, 1. You have a whole grouping that you need to work out. Now, if you were working it out manually, you'd go 4 times 1, 10 times 2, 27 times 3 to add up all your hundreds, and then you would divide by 100. But that's too complicated and too much work. Let the calculator do it for you. And now here's the amazing little trick. Okay, what you have to do is you've got to get it back into the comp mode so that you take out the stat mode, because the only way to clear the calculator is to get it back into comp mode. Now the stat disappears, and when you pick up the stat again, it will be ready for your next calculation. So watch for those that asked how do you get the values in. You go setup, and you want number 2. So write it down as I'm going along. So setup, number 2. Then a whole menu comes up, and you want number 1. Okay, that gives you your X values. But that is if I've got the rainfall 1, 1, 1, 1, or the marks 1, 1. I don't. I have 4 of them that I want to enter. So I'm not going to enter 4, 1, 1. That's too complicated. The calculator can do this much easier. So watch carefully. I'm going to clear it out. Under your mode button. So I've now gone into mode. No, that's not right. That's not right. Let's just go mode. Right. Under your mode button. Okay, there we go. If you scroll down, so if I scroll up, that's what appears. You can get it into degrees, gradients, etc. But if you scroll down, there's another stat button hidden in that mode button. Hit that stat button, and then it says frequency on or off. If you press 1, it will get your frequency on. And now I can press my stat button to enter my data, and now my frequency appears. So practice using that calculator. You will get better at it. For the first little time, just understanding the menu can be a little bit tricky, but you are the technology age. You'll get those fingers buzzing on that keyboard, I think, without any problem. Right, so now we tell the calculator for mark 1, I have 4 of them. So there was a mark out of 1. You press equal, but there were 4 of them. Okay, so every time you want to enter a value, you must just press equals. Then I have, for my mark out of 2, or 2 out of 6, there were 10 people who got that. And there were 10 of them. For those that got 3 out of 6, okay, now it's doing strange things there. I wanted 27 of those. Let's just clear that, and let's go up my 3. That's 3 equals, right. Then for my 4 out of 6, and for my 5 out of 6, and for my 6 out of 6. Where are you gone? There we go. I got 6 equals. Now you'll notice that it automatically puts your frequency at 1. So I'm just going to change the frequencies. There were 8 with full marks. There were 12, and there were 39. Okay, So if I just check quickly, scroll up, 1 was 4, 2 was 10, 3 was 27, then we got 4 was 39, 5 was 12, and okay. So in those 6 steps, my calculator has got everybody's mark, all 100 people's marks. Isn't that amazing? And the moment you press the last equals, it's now sorted itself out, so you can clear it. It's going to keep your data. It's going to keep your data on that calculator. We want to know what is the mean and the standard deviation. So the mean is x bar. That is the mean. We want to know what's the average. What do you think the average was? Well, I think it's around about 4, because that's where most people got that mark. So it looks like it's about 4. So let's see what the calculator tells us. Okay, so once I'm not entering data now. I'm wanting the calculator to do the thinking for me. I want to take the thinking from the calculator. So now you press Shift 1. That's where it does the thinking for you. You can find your minimum, maximum. It will tell you. We can find the sum. You can go back to your data. But what we want is what's happening with 4. And we want to know what is the average. And then you press equals 3,69. That was pretty close. 3,69. Okay? And that's kind of impossible, because you'll either get a 3 or you'll get a 4. So a 4 was a pretty good guess. What about the standard deviation? Standard deviation. And that's a little bit more trickier to pick out. So let's let the calculator do it. We clear, we go back into 1. It's got our data in 4, and we now want the standard deviation, which is 3. And we get 1,17. Okay, so that's 1,17. So what is that telling us? That if, let's truncate these values. If 3 is our average, then to the left, I'm going to get 4 marks. To the right, I'm going to get 2 marks. So one standard deviation is between 2 and 4 marks. That most of the values, not most of the values, but the values around the mean are distributed by 1 mark. So they're not distributed by many marks. Although the question's out of 6, so there wasn't many marks to work with to start off with. But that's how you would work with frequency. Okie dokie. Over to you, Queenie.
All right, I think it's time that we take a quick ad break. But before we do that, I just want to remind you guys about the hashtag Get Connected competition, where we have now come down to a list of 6 final teachers that you guys voted for. So remember to keep liking their pictures on our Facebook page. Share the post so that your friends can also get voting, so that we can get our 10 lucky winners for next week's show. So remember, guys, like, keep liking. You can also go on to Curio and vote there on Curio. It's just a very, very simple procedure. But let's take a quick ad break, and then we'll see you guys after this. Welcome back, grade 11s. If you've just joined us, unfortunately, we are like 3/4 into the show already, but we still have, this is our last segment, so you can still stay tuned with us and find out what we will be covering. And guys, it seems like you're a bit too quiet on the Facebook page. I mean, like, I'm sitting here a little bit bored, trying to get interactive with you, but you guys are just not communicating with me. So please, guys, communicate with us. And also remember that the challenge question is there for you guys to solve and give us the answers, so that at the end of the show, Dina will go through the challenge question, and then we can see who got the answers correct. But then now, let's go straight into the show. We've got a question from Sontaga, and we've also got a question. It's the same question from Delicate, and they want to know how to find the quartiles on an ogive. So Dina is going to do that for us right now.
Wonderful. I'm glad that some of you have already touched base with the Ogives. Ogives. I'm not sure which way to call it. Whichever way, we all know the O-graph, let's call it, which is a graph that, if you think about the marks that we did in the previous question for all the students, all 100 students, it was what we call discrete data. So we wanted to know which child got 1 out of 6. How many children got 2 out of 6, etc. So it was distinct values. when you talk about a class of marks, so if we were saying, let's work with how many children got between 1 and 3, then you're talking about a class. So you no longer know how many got 1, how many got 2, how many got 3. That is when we want an ogive to help us determine where the middle value is when the numbers are clustered in classes. So let's have a look at a diagram, not a diagram, an example. Of such a case. It says the time taken to the nearest minute for a certain task to be completed was recorded on 48 occasions. So we took 48 observations, and the following data was obtained. So children took between 11 and 15 minutes, and you wanted to know how many children took between 11 and 15 minutes. 6 children took that. How many children took between 15 and 19 minutes? 9 children. We got the most children took between 19 and 23, we got 23 to 27, and we got the last people, they took 27. They took half an hour to complete the task. There were 8 of them. So there were 6 of them who took less than 15 minutes, but we got 8 of them who took 30 minutes. So now we'd like to know, where's the middle of this data? Not possible to find. So the mathematicians have introduced what we call a cumulative frequency. So a frequency that gets added on so that the ogive will be a graph that will be able to show us what the distribution is from the lowest value to the biggest value. And then what we're going to do, go to the graph and find the middle. So that's wonderful. We're going to use a graph to find the middle. Okay, so but before we get there, we need to work out what is that cumulative frequency. So onto this table, we'll add another column that will say cumulative frequency, and we will find all the cumulative frequencies. So, because I'm not having anything before 6, 6 will be the first one. Now, the cumulative means I'm adding on, so the 6 must be added on to the 9 to give me 15. Then I add on 13, so I get 28. Then I add on 12, and I get 40. And then I add on 8, and I get 48. And notice that we did 48 observations. So this last number must match the number that you observed, how many observations you made. Now, what are we going to plot? Because we've got so many values here, which one should we choose? Well, mathematicians have chosen the last value. So we are going to plot 15 on the x-axis, so this will be my x-axis, the time, and on my y-axis will be my cumulative frequency, 6. So I'm going to plot the point 15, 6. Then I'm going to plot the point 19, 15. Then I'm going to plot the point 23, 28, 27, 40, 30, 48. So time is going to be on the x-axis, the cumulative frequency is going to be on the y-axis, and we always plot the end of the class, end limit, okay, with the cumulative frequency. Okay, because that's the only way for us to be able to find the halfway mark. So we're going to plot all those, we're going to see what it looks like, and then we're going to find the halfway mark. So let's do that. Okay, so the first question was to determine cumulative frequency, which we've done, and then draw an ogive of the data. So the way we draw that is my end limit on the x-axis, my cumulative frequency on the y-axis. These are the points that I want to plot. So let's go and plot those. Okay, and let's determine the median and the interquartile range, which is one of the questions that the viewers asked. So let's do that. Okay, we've plotted our cumulative frequency on our y-axis and the time in minutes. Okay, so if I make my graph really nice with all the minutes on there, remember I had 15 minutes and there were, how many were there at 15 minutes? Let's just go back there. There were 6 of them, okay? And then 19 minutes, there were 15. Okay, let's go back there. And we've got, 15, 6, because each one of these units is 2. So 2 people, 2 people, 2 people. Okay, so that's 10 people there. And then we had we 19, 15, etc. So we put all the values and then you join them with a free hand. Now, there's always a worry about what's happening at 0, and there were no students that got less than 11 minutes. Everybody completed the task in 11 or more minutes. So 0, there were 0 children who got less than that. So that would be where you would ground it. Now, once you've got the graph, you've got the minimum value, you've got the maximum value. How many children were observed? There were 48 children observed. Okay? You will now find, where is my halfway mark? What is the halfway mark between 0 and 48? And that would be 24. So that becomes your median. Your median is where the 50% mark is. And so I go to 24, there's my median. And I go across to the graph and I read it down, and my median is 22 minutes. So that is my median. Okay, so you can actually write on here that my median is the halfway. So we had 48 observations, which means that therefore the 24th observation would be where my median would lie. Okay, because remember, the median bisects the data, cuts the data in half. So 48, 24 is my median, the 24th observation. Okay, then what about the quartiles? Well, now I take the 24 and now I halve it. So what happens when you halve 24? You get 12. 10. So 12 is about there, and we go across, and that becomes our Q1. It's 18 minutes. So that would be Q1. And then let's work with pink. Where would my third quartile be? Well, if it's 12 minutes this side, then it must be 12. So at 36 would be my Q3. So you would go to the graph, and you now read from the graph, you'd go down, and that would be my Q3, that would be 25, 26, so it was 25 and a half minutes. Okay, so now I can talk about an interquartile range, my IQR, and I can talk about a minimum, I can talk about a maximum, and I can draw a box plot from that data. So if I took a little box plot and I had 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27. I think it ends at 27. No, I think it carries on for more. So let's go 10, 9, let's go 11 there. Okay, so if we look at the box plot, then I'm going to 12, 13, 14, 15, 16, 17, 18, 19, 20, 22, 23, 24, 25, 26, 27, 28, 29, 30. Okay, so my minimum is 11. My 18 is my Q1. My median is at 22. My 25 and a half is my Q3. And then what's our maximum? Oh, they took half an hour, remember? Yes, they took half an hour. Okay, so you plot all those points. Whisker to Q1, box, interquartile range, how is it spread around the median? And then we can draw that. So we can see that the data is not symmetric because this whisker is much longer than that whisker. So I would say that this whisker elongates the data to the left, so it's skewed to the left, which means that these values are widely scattered, where those are a lot more clustered. And that is really how you would describe grouped data. So when you've got a class of values and you don't know how many of each were in that class. So that's how you would address that. And then just to wrap up, let's just go back to the Riverine Rabbit. Did any of the viewers comment on the distribution of the box plot?
I don't see any comments relating to that.
Okay.
But we have a few comments for you, dear.
Yes.
We have, okay, Audrey would actually like to know if you can exactly explain what Ogive curves are. I think he's a bit confused on that. And Wavudi would also like to know, like, how do you get the data in the table made in question 2? So maybe if you can just make that clear.
How do you get the... Okay.
Okay, we don't.
How do you get the question 2? Okay, let's just look at question 2. Yeah,
Okay.
question 2, let's just have a look. What about how you get that onto the calculator?
I'm not sure exactly what Precious would like, but she says how to get the data in the table in question 2.
Okay, the data was given to you.
Okay.
So these values must be given to you, and then you've got to get them into the calculator to get out your mean.
Right.
And you know what? Next week we're doing a lot more of interpretation. I noticed that your interpretation skills aren't up to shape because you couldn't comment on the distribution, but stick around, we'll talk about that next week again.
Yes, so Precious, just tune in with us again next week, and then maybe we can get a clearer idea of exactly what you wanted to know. But for now, guys, it's actually a wrap. We have reached the end of our grade 11 mathematics show. But before we leave, I'd like to quickly send a shout out to Dumelo, and he says, please say hi to my classmates at Hlabi High School. And this is from Dumelo Machaela at Mzansi. Love you guys, and please study hard for your exams. So that is the word of encouragement for a fellow mindsetter. Guys, please study hard. Make sure that you set up a timetable for yourself and you stick to it. So it is the end of the show, and for me, it is goodbye. We'll see you guys next week.